All right, everyone. New year, new semester. So, module one's going to be properties of exponents. I guess I don't really need this one. So, let's get on with this. Hope everyone had a good year. Properties of exponents. All right. So, for this video, our goal is to reason abstractly and quantitatively. We're going to be talking about exponents and how to write a monomial, meaning one term, mono meaning one term, um, expressions, and ratios. So ratios, we're talking about fractions. We're talking about fractions of one term expressions. And we're going to rewrite with radicals, rationals, and exponents. So there's a lot of these here. I really wish that Edmentum would not give you the actual state standards and explain these a little bit more. But basically, what we're going to be doing is dealing with polynomials, integers, under closed operation, meaning that a polynomial um, can when a polynomial is going under addition, it should still be a polynomial. When you're doing a polynomial with subtraction, it should still be a polynomial. That's what it means by closed operations, meaning that if you're doing something, it shouldn't change the fact that it's a polynomial. So let's get into this. So again, I feel like they just worded it very complicated for you guys. So let's do this. So if we're talking about this and we want to expand this idea, this is the expanded form. So if we're doing 3 squared times 3 cubed, 3 squared is 3 times 3, and then cubed is going to be 3 times 3 times 3 because there's 3 threes. So if we want it in an exponent form, we want a 3 5 times. So in other words, we're going to do 3 to the 5th power. So if you see here, when we're multiplying, we just add the exponents. So this one, we're going to have 2 to the 1 times 2 to the, or 5 to the 1 times 2 to the, times 5 to the 2. Oh my gosh, my brain is still on break mode. 5 to the 1 times 5 to the 2. So we're going to do 5 to the 3, where we have 3 5s. So this one, same thing. We have 3 and 4. So if I counted these, there should be 7 of them. So we have 8, or we have 7 eighths. So 8 to the 7th power. This one, if I add these two, there's a 6 and a 2. 6 plus 2 is 8. So in other words, there's 8 7. So it's 7 times itself 8 times. And that's pretty much how exponents are when we're multiplying them. So this was our warm-up. We should already be a little familiar with this. So an introduction. So no matter where you live in your area, it's governed by a set of rules, laws. So this is what we're going to be talking about, this idea of closed operation if you do a polynomial. And a polynomial, I've been using that term a lot, but a polynomial just means that we have x to some power and we're always adding different x's. They could have a coefficient, meaning you're multiplying them by a certain amount. So we have 3 x's here. They could have different powers, so you could have like x to the 4th. We cannot have something like 2 to the x. This is known as an exponential. So basically a polynomial is you're multiplying by x with some power. And even you can even argue that 5, the number 5 is a polynomial because it is essentially x to the 0 power. X to the 0 power is just 1. So 5 is technically a polynomial, just like x by itself is technically a polynomial. Um, So let's go on with this. So law of exponents. So one of the first laws, well, first we kind of want to know what is an exponent. So an exponent is something like, I don't know, 2 to the 5, where 2 is known as our base. The 5 is known as our exponent or power. So either one of these works. So just the key point is remembering what a base is. That'll be helpful, especially once we start getting into logarithms. But for right now, just remember what a base is and what the power is. All right, so moving on here. So, and we can have exponent on the bottom. The way we do this is with a negative power. A negative power means that it moves the base from the top of a reciprocal to the bottom. So the top of a rational to the bottom of a rational. That's what this negative does. Negative does not mean we're subtracting. Think of it this way. When we had this like 2 to the 4 times 2 to the third, we got 2 to the 7. We added them. That's from multiplying. But what if we divided? Well, if we divided, we wouldn't be adding them anymore. We would be subtracting those powers. So negative, at least when it comes to exponent, means division. So it's kind of like a tier above it. So remember how when we first learned about adding the same number over and over again, it's like, oh, 2 plus 2 plus 2 is the same thing as 2 times 3. We have 3 of these. Well, what if you keep multiplying them over and over again? Well, those are exponents. And if you keep dividing them over and over again, they're negative exponents. And we'll see more of that later if that's confusing. So, and then another rule is anything to the 0 power is automatically 1. And the reason why that is let's say we have 2 to the second divided by 2 to the second. Well, this is just 4 over 4, right? Which is 1. Well, another way of looking at this is 2 to the second divided by 2 to the second. That means we're looking at 2 to the 0, which is just 1. Because what's happening is we have the same number divided by the same number, which is just 1. So that's where that rule comes from. A lot of people are like, that doesn't make sense. Shouldn't it be 0? But it's based on this idea of fractions. So that's where it comes from. That's why this is all, anything to the 0 power is automatically 1, whether we know what that base is or not. All right, so moving on. All right, so this one, again, the multiplication rule just means we're adding everything together. So you can see that right there. So there's one of your rules. I recommend writing this down in your notes. It's honestly probably in the guided notes. So if you go down to our folder here with your guided notes, there's probably a spot where you can fill it in. So what a base is, what a power is, what an exponent is, and then here are the rules and everything that you would need. So I always recommend filling these out, especially before your mastery test. It just kind of helps you out. All right, so let's go on. So basically what this is saying is even though these exponents are different, you can always do them together because multiplication is multiplication. You can always do it in any order. So here's our product rule, meaning that if you're multiplying, you just add the powers. Well, if you have a power to a power, power of a power, you just multiply the exponents. Well, what if you have two things multiplied and then you have an exponent on the outside? That's the same thing as basically distributing this m to both of them, which is how we get this. Now, if you have quotient, that's where our subtracting rule is. So just remember, product, multiplying is adding exponents. Quotient means subtracting exponents. And quotient of power is very similar to power of, or blah. Quotient of power is very similar to power of quotient. Oh, power of quotient and quotient of powers are basically the same thing. I don't know why they made it all weird like that. That's very weird. These will kind of start making sense with some practice, though. So if you're a little confused, Like I just got confused. I was like, wait a minute, what is all this? Um, it's fine. It's just them being weird. You'll understand it once you get that flow. The most important ones I think are these two rules. Uh, Product of powers, that just makes sense because you can always just do what they did in the beginning, which is like, oh, it's 3 times 3 times 3 times 3 times 3. And you'll see that you're just adding those. Power is a lot of people get this one confused with that, but just remember there's no base here. So the only thing you have to interact with is that power. So you want to multiply those powers. All right, let me clear the board. So we're going to simplify expressions now. So simplifying the expressions. So one term. So in other words, when we want one term, every base should have an exponent. So this 5 technically has an exponent 1. Now, if we look here, this exponent doesn't have a base. So it is not simplified. You're going to want to distribute that 3 over so we can simplify this. All right, so let's take a look at this. So to simplify this, so if you look here, see how they distributed that 3? They took this 3 and they went 3 to the third power, x to the x squared to the third power, and a y squared to the third power as well. So they're distributing it. Now they're going to do the math. So what's 3 times 3 times 3 is 27. What is 2 times 3 is 6. What is 2 times 3 again? That's also 6. And then because one of them's a negative, is that a negative 2? Am I looking at a negative 2? I can't see if that's a negative or not. Oh, that is a negative 2. I just saw it right now. Because it's a negative 6, you can barely see it to be honest. That means the negative means it goes to the bottom. So any negatives will automatically go to the bottom. If you have any negatives on the bottom, you have nowhere to go but up. So any negatives on the bottom will go up. Going to the next one. So this one, we would have to distribute this 2 just by looking at it. And they did distribute it right here. To the y and as well to the 4, and then 4 to the second power is 16 because 4 times 4 is 16. This is an important thing. This negative is only touching that y. So what'll happen is, oh, they're actually doing it a different way. They're like, hey, let's group everything together. So these y's would go together and you get y to the 0. The 5 and the 16 go together. The x and, well, there's nothing to go with the x, so it's just there. And remember, now we're going to have y to the 0. Anything to the 0 power is automatically 1, so our answer is only 80x. The y's kind of cancel each other out. The way I was thinking about it was we'll have 8y on, or 8 y's on top and 8 y's at the bottom, which will cancel out, but they're like, let's just use our rule of adding the powers. All right, so let's take a look at this. Well, you guys saw the answer, but let's see why that is. So give me a second here while I do this. So we have negative 5 CD to the negative 4, D to the negative 4, times 2 CD to the squared. So we're going to want to distribute this 2, and we get negative 5C over D to the 4th. I'm getting rid of this negative because I just don't like having the negatives there. Times, and what's important is when you're multiplying, it just goes on the top. 2 squared, C squared, D 2 to the second. So that one we're not quite done yet. We kind of have to do some math with it. So this becomes negative 5C times c squared times 4. I kind of combined this c squared with this c, just brought them closer together to make this easier later. 2 squared was 4, and this 2 times 2 means d to the fourth, all over d to the fourth. And right off the bat, I can see that this d to the fourth is going to cancel out with this d to the fourth. You're going to have this 4 times -5, which will give us that -20, and then 2 plus this invisible 1 is 3. So I know I did a lot there, but basically we multiplied these two together. Um, I feel like the canceling out is self-explanatory. And then we have C1 plus 2, because there's an invisible 1 there. And that's how we end up getting that as our answer, our -20x to the third power. All right, so moving on. So again, these rules are should be a little review. If it's difficult, again, always feel free to make an appointment with me. So here's some more examples of how to do this. We're going to distribute that 4. This one we're going to subtract. So there is a combination of rules that can go together. So let's go to the next one. All right, so let's simplify this expression. So that was the expression of this first top one right here. So we're going to distribute the 4 to everything. Going to multiply our powers out. In this case, this was -2 times -2 times -2 times -2. I was having a hard time keeping track of that in my head. So 2 times 2 is 4. -2 times -2 is 4. So we have that twice, which is the +16. And now we have x squared to the fourth. So that's x to the 8. And then we're going to have 3 times 4, which is that. Now we're going to do any canceling out. So if we notice, we have more x's on the bottom than we do on the top. So what's happening is we're going to get that -4, which means there's 4 more on the bottom, so we're left with 4 at the bottom. There's more y's on top, so we're going to be left with the y's on top. They like to make it a negative. I like going like I have more x's on the bottom, and you can kind of see that. I'm going to do that with a simpler one right now so you can kind of get the idea of what I mean. So if I have x to the third over x to the fifth, I have x over x, 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 x. This cancels out, this cancels out, this cancels out, and I'm left with 1 over x times x, which in other words is 1 over x squared. We kind of have to put this placeholder of 1 there to make it easier. All right, so next one is we're going to do simplifying expressions here. So let's take a look at this. Let me put the unanswered one. So we need to read the instructions and drag. So we're going to be dragging a lot of stuff here. All right, so expression laws. It's either quotient or product, it looks like we're doing here. So power of a product. So power of a product. So product means multiplying. So we're going to be multiplying together, it looks like. And this is product of powers. Oh my gosh. I'm not a big fan of the names. So power of power, that means we have a power to a power. So let's eliminate that one first. So a power to a power. That to me is going to be this one. So we have the 5, x to the power 5 to the power 6. And then we're going to do product of power. So that means that that means of powers. That means the powers are being multiplied together. So we need powers that are being multiplied together. So to me, product of power, power of a product. So that means that there's a product. So power of product means that there's a product and we have a power to it. This one means we have 2 powers that are being multiplied. So these are 2 powers being multiplied. That was very confusing. We'll see if my logic makes sense in a bit. quotient of powers. That means we already have powers, we're just dividing them. So here's our powers that are being divided, and this is power of a quotient. So that means we already have a quotient, we're just doing it to a power. So let's see how right I am on this one. Cool, correct. So you kind of have to think of a product. So there's a product and it has a power. This is product of powers. That means we have powers already, we're just doing the product. Quotient of powers, that means we already have powers and we're taking the quotient, meaning dividing. Power of quotient, that means we have a quotient and we're giving it a power. So it's a little complicated. I'm not the biggest fan of vocabulary that's similar, but at least we got it out of the way. Next is which expression is correct. So just remember, whenever we have an expression to a power, we're going to distribute that power. So in other words, the easiest way to figure this out is, what is -4 to the third power? Well, -4 times -4 is +16, but we're going to have an additional -4. So that means this is the only one that can possibly be our answer, because that's the only one that has 4 to the third. And you can figure out the rest too, because you have a to the third, which that also has, and you're also going to have b to the third. So this one doesn't have a to the third, so we know this one can't be it, especially since it doesn't have that -4 to the third. This one, they're trying to trick you because it's like, oh, that third can also be with that 4. That is not correct. That third needs to be distributed to that 4. This one, they're tricking you too, because they're just doing 4 times 3, which is not the case. -4 to the third is supposed to be -4 times -4 times -4. It is not -4 times 3. So the only possible answer is this one. All right, let's go on to the next one. Oops. So what I always do with these, when you have a rational function, you're going to pretend everything is separated. Well, what's 20 divided by 4? 5. All of them have a 5 in it. How many A's? So we have 8 A's and 2 A's on the bottom. So that means we're going to have 6 A's left, because it's 8 minus 2. So we're going to have 6. So right off the bat, that means that the only answer can be this. Let's pretend we didn't know that. So we have b times b over b. So one of these b's cancel out. So we have one b left. And because this is the only one with one b, that one is also the answer. So they kind of wanted you to know your exponents for this one. So for this activity, I would say I did really well. If you're having trouble with some of them, you can say something like, oh, I mix up power of products with product of powers. And that, if you're wondering, because it's so confusing how to do it, power of products is when you have something like x times y to the power of 3. Product of powers is when you have something like x to the third times x to the fifth. You already have the powers. So it's very confusing, but that way anything that you're having trouble with, if you're having trouble with quotients, write that down. These are intended to help you reflect on what you're having trouble with. All right, so let's go to the next slide, which is probably just the summary. Yep, so the summary, make sure you either watch the video or read your notes. That's a good way to get started. And this one breaks down all the rules for you, so that's great. You're going to be in good shape. I would honestly take a picture of this or copy and paste it into a Google Doc so you have notes, anything to help you with that mastery test. All right, and that's our first module for the new year, guys. New year, new semester. All right, I'll see you guys in the next video.